Hello, in this video I'll be discussing the simplest form of car tyre foot pump, the single stage pump. This is a one piston operating in one barrel. Many different designs of single stage pump were produced in the first half of the 20th century by various British manufacturers. Firstly, I'll show you a selection of pumps and point out their different features and characteristics. I'll then discuss the common service items that are usually needed to get an old pump working and working properly. Here I've picked out a selection of single stage foot pumps just to illustrate the different design features that you can find in them. The first three here are pumps where the exit point is at the back. The PCL Elf, the Kismet Popular and the Dunlop Junior. The exit points are in the same place at the back. They all have coiled springs to carry out the return after the downstroke, but they have slightly different closing catches on each of them. The Dunlop has a tapered coil spring. The other two, the Popular and the PCL Elf, have basically parallel coil springs. So these are three of the most common single stage foot pumps: back entry, coiled springs with slightly different closing catches on the frames. If we move along, we see some different styles. This Airite has the exit point at the front, as does the Sutty Golden Tornado, and the Wood Milne is similar with the exit point at the front. These two here have board-on pressure gauges on them. All of these three pumps with the entry points at the front have torsion springs to carry out the return. The Airite has the single torsion spring, the Sutty two torsion springs, and the Wood Milne again a single torsion spring. Again, different closing mechanisms, levers on the side here, a wire loop at the back and another wire loop at the back on the Airite. The other feature of these three pumps here is that the non-return valve is located at the front, just behind the exit point, whereas with these three pumps here, the back entry ones, the non-return valve is located behind a brass nut at the back there. The Airite is a particularly interesting pump because the non-return valve has to be located within the hose tail connector, and these hose tail connectors with the inbuilt one-way valve or non-return valve are very difficult to come by these days, so repairing an Airite is not always easy. For the Sutty and the Wood Milne, the non-return valve, a spring with a ball bearing, is located within the body of the pump but behind a screwed bung just in the outlet aperture. So that gives a good overview of the different types of single stage pump that you might encounter, and we'll move on next to discussing some of the individual features within them that need attention during overhaul and maintenance. Before we start talking about the overhaul and servicing of a single stage foot pump, it's useful to talk a little bit about the basic working principle. Here we have a single stage pump at the top of the upstroke, just ready to pump. On the downstroke, the piston, which at this point is near the top of the barrel, moves downwards, compresses air in the barrel, and the air exits via a non-return valve located here and goes into the tyre. At the same time as the piston is moving down the barrel, the suction behind the piston draws air into the barrel above the piston through this small hole here, and also air can be drawn in the aperture between the piston rod and the barrel end cap. So on the downstroke, two things are happening. Air is compressed and expelled, and the new charge of air is taken in behind the piston. On the next upstroke, this charge of air passes the leather piston washer in the reverse direction to charge the barrel in front of the piston, ready for the next downstroke. So that's the basic principle of operating a single stage pump. And the important thing to mention about the washer in here is that it must be sufficiently flexible and designed correctly so that air can pass in the reverse direction and end up in front of the piston, ready to be compressed and expelled. The purpose of the non-return valve in a single stage pump is to prevent backflow of air from the tyre once delivery has taken place. So on the downstroke, the one-way valve opens and allows air out of the pump into the tyre, but on the upstroke it closes and prevents backflow from the tyre. Here we've got three typical one-way valves. I've taken them out of the pumps so you can have a look at them carefully. Here for the Dunlop Junior, we have a bolt with a very soft spring attached to it and a ball bearing, in this case 3/16 diameter. For the Airite, the one-way valve is a small ball bearing which actually sits inside of the hose tail and moves backwards and forwards. In the Wood Milne here we have a slightly different arrangement, ball bearing 3/16 again with a soft spring, in this case kept in place by a small screwed fitting which screws into the aperture to keep the spring and ball bearing behind it. The ball bearing acts as a non-return valve by sitting in the aperture and blocking off the flow. In each of the pumps there's a very small hole at the outlet where the ball bearing sits. The springs that you see involved in these two, in the Wood Milne and the Dunlop, are very soft springs. Their purpose is just to keep the ball bearing in place over the orifice, but not to press it down at all, just to keep it in place. Closure takes place, or blockage of the flow takes place, by air pressure, which forces the ball bearing into the small hole where it sits. Now, the most important thing when you find a single stage pump is to check that the one-way valve is in place, ball bearing, spring or otherwise, because quite often they go missing. People don't really understand what they're there for, take the pump apart and things go missing. So that's the first check you should make on a single stage pump when you get it. Second, if you find it in place and you find it okay, it's a very good idea to have a close look inside the aperture, and where necessary think about cleaning it out with maybe a cotton earbud or similar with paraffin or petrol on it to really clean out the contact surface, because even if there's a tiny bit of grit or any other piece of material in there which will prevent the ball bearing seating, you will get a leak and pumping will be very inefficient. So there you have it. Different styles of one-way non-return valve, but all essential for a single stage pump to work properly. If the spring has gone missing, one can often fabricate or design or make a replacement by taking apart one of those spring-loaded biros or ballpoint pens and cutting a little piece of spring to the right length. If one finds the ball bearing pitted or otherwise damaged, it's best practice to replace them. As I say, in these two cases, the ball bearing's about 3/16 diameter inches. In smaller pumps, they can be smaller. In larger pumps, a bit bigger. If you don't know what size the ball bearing is, then maybe the only approach is to check a few sizes and see which works the best. A very important thing to check when overhauling an old pump is the state of the leather cup washer on the piston. Here we have a typical arrangement where I've dismantled a pump. We see the piston rod, we see the piston backplate, the leather cup washer with a hole in the middle which fits against that backplate, and then two locking washers which pinch the washer tightly against the backplate to stop any leakage. That's the general arrangement. When one inspects the cup washer in an old pump, one often finds it split or torn, letting air through, and the only solution is really to make another one. I make my cup washers using special jigs. Here's an example of a jig. It's essentially a circular piston which goes into a hole, and one can actually use natural vegetable cured leather, wet it, and then when one pushes the piston into the hole, it forms a cup washer like this, and when dried it retains its shape. When one's finished that, one needs to do some trimming to get an even front edge to the skirt of the cup washer, and here you see I've marked it with a line, and that'll be trimmed soon with this surgical scalpel to give an even front edge to the skirt on the cup washer. It's important to use natural untreated leather, tooling leather. This is leather that keeps its shape when wet formed and dried out, and typically 2.5 millimeters is enough for most cup washers. The thickness, if it's too thick, it's not flexible enough. If it's too thin, it won't seal. 2.5 millimeters is a good average thickness of leather. Normally, when one opens up a pump, an old pump, one doesn't see it in such a clean situation as this. It's often covered in old mineral oil and grease, which is bad for the leather. It rots it and degrades it over time. So one is often faced with cleaning it out, getting rid of all of that old mineral oil and grease before fitting the new cup washer. When one's fitted the new cup washer, it should be oiled, but the proper oil to use is compound neatsfoot oil. This doesn't degrade the leather, it keeps it flexible and supple, and will retain its usefulness for much longer. That's compound neatsfoot oil. Compound means it's got a small antifreeze element in it to stop it going solid if the pump spends a cold night in the boot below 0 degrees centigrade. The other important thing, if one's re-oiling a pump, is to make sure that the internal barrel where the washer moves is also cleaned and fully oiled with compound neatsfoot. So those are the most important things to bear in mind when examining the piston in an old single stage pump and making new leather washers. We spoke earlier about the various types of spring you can find on a single stage foot pump. The compression springs on these two, the Dunlop Junior and the Kismet Popular, and torsion springs on these other pumps, the Airite, the Sutty and the Wood Milne. Unfortunately, from a servicing and overhaul viewpoint, if a spring is broken, there's very little you can do. Spring steel is very, very difficult to weld, and it's very unreliable if you do manage to get a welded joint. So the message is replace, if any doubt, with one exception, and we'll talk about that in a moment. The most delicate of all the springs I find are these torsion springs on a Sutty Golden Tornado. Many times they break, and I've seen so many pumps thrown away simply because those springs are broken. What I've done for all the common pumps around, I have sent samples to my spring maker up in Redditch and have a reasonable supply of all the common springs for pumps. So if you needed a spring to overhaul your pump, get in touch and I might well have one. I mentioned one exception, and that's the compression spring. We see this one here dismantled from the PCL Elf. Often one finds, rather than being broken, this spring over the years has taken on a permanent set and is much shorter than it should be, up to an inch in some cases. There's two approaches if one wants to get a bit more life out of a spring like that. One is to stretch it very carefully, try and get it back to its original length. Unfortunately, this approach tends to disappear after a while. It resets at its shortened length. So that's a temporary fix. The other approach I've found more useful is to actually put a few extra packing washers, impact washers, behind the piston backplate and the barrel end cap, which in fact effectively shortens the length of piston rod which is outside the barrel, and therefore will tighten up a spring that was originally a bit too short. This is a much better fix, I think, for a spring, for a shortened spring, than trying to stretch it. And as long as you don't have too many of these packing washers, it won't affect the performance of the pump very much. The swept volume will be very similar. So that's the best fix I've found for a parallel compression spring, or indeed tapered compression spring like we here have on the Dunlop or on the Popular. Some extra packing washers behind the piston backplate can often do the job and tighten your spring up and give you years of decent use after that. But as I said, in the majority of cases, if you've got a broken spring, the only approach is to replace it and get in touch. I may have one for you for your pump, or at least I can put you in touch with a spring maker who can make you up a replacement spring if you have the originals to act as a pattern. If you're overhauling an old single stage pump, it's most likely that you'll have to consider replacing the hose system. That's the system connecting the pump to the tyre. Most old pumps were provided with braided hose, that's rubber hose covered with cloth, but I tend these days to use plain rubber hose instead. The cloth covering can cover up all sorts of defects and perishing. I use R6 fuel hose, that's 7mm inside diameter and about 14mm outside diameter, and this shows a length of it which suits any old pump and looks the part. To connect it at its ends, one's got a couple of options. There's a Jubilee clip at the top, but I tend to use a two-eared O-clip which is crimped up with sharp-nosed pincers. If one needs to replace the hose tail, the most common fitting is a 1/8 BSPP hose tail, which I show here, and that will fit most of the pumps along here. If, however, you want a hose tail, or you need a hose tail with a one-way valve in it, you can't use the BSPP one, that's a straight through one, and you have to use the original one with the one-way valve incorporated, like in this Airite. Now at the other end of your hose you need a connector to connect to the car tyre. In many old single stage pumps you'll find one of these thumb lever type connectors. The one on the left is a metal barrel with a neoprene plastic thumb lever. The one on the right is all metal. These can be refurbished by knocking out the pin, taking the thumb lever out and replacing the rubber insert, and often that works fine, but one's never sure just how much fatigue life has been used in the components during their lives, particularly the thumb levers, so one's always running the risk of an old valve connector after refurbishment breaking on you. So I tend to use modern equivalents. The one on the left is a PCL equivalent you can get off eBay, and it's a very similar one to the antique one there. The one on the right here is an all metal one, again a very similar equivalent to the original, and I would tend to use those rather than the older ones. However, if you wanted to refurbish an old one just to keep the pump as original as possible, then by all means go for one of these and refurbish it, but always keep one of these spare in case it breaks on you. So there we have it. The refurbishment of a single stage pump usually needs a new hose system, and it's good practice to replace all parts of it to give yourself the maximum life ahead of you. We discussed tyre valve connectors in the earlier video clip, but it's important to just mention one point of detail in relation to them. It's necessary on modern tyres and in modern tyre valves to have a central peg in the middle of the tyre valve connector. You can see the central pegs here in these two connectors. These are necessary to mechanically depress the Schrader valve core in the tyre valve so that air can enter. Now, if you examine an old single stage pump, it's quite likely that you'll find a connector without this central peg, and that's because in the olden days the Schrader valve cores were much weaker, and they opened under pump pressure alone to allow the air into the tyre. But modern tyre valves have a stronger Schrader valve and need this central peg to mechanically depress it to allow air into the tyre. So whenever replacing a tyre valve connector on an old pump, make sure you're using a modern one with the central peg in it to mechanically depress the Schrader valve. In the olden days, pump pressure alone was enough to depress the valve and let air into the tyre, and then when pump pressure decreased, the Schrader valve actually then acted as a non-return valve. It closed up by itself, but nowadays this cannot happen. You must have a central peg in the middle of your tyre valve connector. We spoke earlier about circular board-on tube pressure gauge dials which were fitted to some single stage pumps. Not all, and in fact not many. These are the only two of very few examples, the Sutty Golden Tornado and the Wood Milne, mainly because these dial gauges are somewhat delicate, easily broken, and we'll talk in a moment about them not being particularly accurate. But given that these dial gauges do exist, and you may find a modern one fitted to an old pump, retrofitted, it's worthwhile understanding how they work and seeing if there's any chance of repairing one if you indeed find it broken. To explain the workings of them, it's useful to look at a large example of a board-on tube pressure gauge. Here we have a hollow copper tube in the form of the arc of a circle, and it's hollow and of a flat elliptical cross section. So when pressure is applied to it through the base, it tends to move rather like a hose pipe on your lawn when you put pressurized water in it, and the end of this tube will move along a straight line proportionally to the pressure that's exerted. So we have what's called a linear relationship between the movement of the end of this board-on tube and the pressure applied. For the circular dial gauge, this movement at the end of the tube has to be converted to a rotation, and this is done with a 2-lever slider crank mechanism here, which converts the movement to a rotation and thereby to the movement of a needle around a circular gauge. So that's the principle. The main problem, apart from these being very delicate and broken, is that they're not always accurate. We said there's a linear relationship between the movement of the end of the tube and the pressure, but there's not a linear relationship when it goes through this slider crank to the rotation of the dial, of the needle on the dial. And that means that in practice the board-on tube gauge can be only accurate at 1 or 2 or sometimes 3 points on the scale, but normally only 2. So the designer and the manufacturer has to decide which 2 points on the gauge it wants the gauge to be accurate for, and then at other places you must accept the fact that it's inaccurate by up to 5, sometimes higher psi. So you can get a mismatch or an inaccuracy of 5 psi at some points on the gauge, but 2 points it'll be accurate. Unfortunately, without a detailed analysis of the gauge and of the crank mechanism, one can't know which 2 points on the scale are accurate. That there is a problem. I know about this because I analysed these slider crank mechanisms as part of my final year engineering degree project and produced guidelines for how to design them, the lengths and the offsets to give the maximum accuracy. But the bottom line is that they can only be accurate at 2 points on the scale. So that's the reason for them sometimes not being used very often. But having said that, they do give a broad indication of the pressure, and this can always be checked with a handheld gauge if one wants to be more accurate. Finally, if one gets around to trying to mend one of these, now I'm not talking about the big one, I'm talking about one on a small scale like this. It is fairly delicate inside and one needs a watchmaker's skill to get in there. But quite often one finds that the linkages, the connection points in the linkages are broken, and one can repair them and get the thing moving. That's the most common problem one has. Occasionally, of course, one finds that the board-on tube has indeed has developed a leak, and generally speaking that's beyond repair. One can't get in and mend that, because if one tries to solder it or do any other repair on it, one changes then the stiffness of the board-on tube. So there's the quick summary of the board-on pressure gauge. Interesting, useful in the sense of indicating an approximate pressure, very delicate and easily broken, can sometimes be repaired, but generally speaking an attractive feature, which if you've got one on your pump, keep it. As an alternative to board-on tube dial gauges, several manufacturers of single-stage pumps offered inline pressure test valves let into the air line, so pressure can be taken with a handheld gauge without disconnecting. This shows a typical one which was an optional extra on a Kismet Popular. It's a simple construction with a test valve which is essentially the same as a car tyre valve, with a Schrader valve core in it, and when applying the pressure test apparatus, either a small pencil gauge or a dial gauge, one can take a reading directly from that. And this one has an interesting and nice protective cap. These were offered as optional extras on pumps. You don't see many of them around, but where you do, they're well worthwhile replacing the valve and getting them working if necessary. As an alternative, one can make up one from components yourself. Here's an illustration of a T-piece with a tank test valve, a little pressure test valve at the top, and two hose tails, one at each end. These can all be screwed together and provide an alternative to an inline pressure test valve, a little bit bigger and a little bit more cumbersome, but still very useful and very effective. These components can be obtained easily off eBay or from a pneumatic components specialist. So most people would actually prefer one of these pressure test valves to a board-on tube gauge, because in principle they're more accurate and far less likely to be damaged or made not to work. That's the end of the video. I've tried to cover the main points you need to think about when overhauling an old single stage pump, and I hope you found it useful. If you need any more details or need to contact me, the contact details are next.